Alright, so we're doing kinetic energy today. Yesterday we did potential energy. So this is what we did yesterday. Just to refresh everybody, this is energy in joules. All these three letters is one number. It's gravitational potential energy. And there's different kinds of potential energy. We could have PES for a spring. We haven't done that yet though. We just did gravitational potential energy. This one's joules. Mass is kilograms. Gravity is meters per second squared, which is that negative 9.81 number. This one always has to be negative. And because energy has to be positive, and because when we were doing things, when I had this object up here, it has the potential to fall down 1 meter or whatever we did. So its height would be -1 since it has the potential to fall down 1 meter, or school bus. Anyway, we're doing kinetic energy today, which I think is slightly easier, despite it's got the 1/2 in the squared here, and this just has m times g times h, because you don't have to remember to make h and negative, and there's no g, so you don't have to remember 9.81, remember to make that negative. This one just has some numbers, and it makes it a little bit easier to do some of these in your head, which is nice. I think actually you could probably get away with doing this whole assignment without using the calculator with your mental math, but feel free to use a calculator, that's what they're there for. So I'm going to do an example of this. I'm going to show you what kinetic energy is first using my trusty school bus. Boom! Are you ready for a demonstration of kinetic energy?
Will every single problem on this thing be that familiar?
Yes. Everything yesterday was the PE formula, everything today is the KE formula. Tomorrow we're mixing it up, so you'll have to figure out which is which tomorrow. But we'll get there tomorrow. We're doing just the KE today. So kinetic energy is whenever something has motion. That's what kinetic means. Like you know those kinesiology people? That's the study of movement. That's why kinesiology people do, they figure out how your body moves, and they help you with your rehab when you get injured from moving your body weird, and they know how to move it to fix it up. So here you go. Kinetic energy. It's moving. It has kinetic energy. Nice. Let's see, who can help me out? Y'all cover your noses. I see 3 old noses. 3. Thank you.
Caleb loved it.
Hey, you still got to cover. Cover your nose, please.
My nostrils are pointing away from you.
Good, but okay. Well, let's see here. Joseph, will you give me a number of KEs that I can use? So the number of joules for the kinetic energy. 5. 5 joules.
That's killing us.
And let's see, I'm going to plug in something for M. M is mass in kilograms. Who's next? Josiah, will you give me a number of kilograms for my mass?
4.
4. Hey, that's what they said last time. How about that? And then we're going to solve for velocity here. So this is one where we're going to have to take a square root at the end. Can we do this? Joseph, to make this a little easier for me, I am going to change this to 50 instead of 5. Okay? 50. All right, I'm ready. So, all right. We want to get V by itself. Like first we're going to get V squared, and then we're going to get V, and then we'll be done. But V squared is way over here, and it's got these 2 things next to it. So one thing we can do is multiply these, and then we'll only have 1 thing next to it. So let's do that. Simplify. Half of 4 is 2. So we got 2 V squared. There. All right. So I'm almost to where V squared is by itself. I just have 1 number now instead of all this. It says V squared times 2. So to make that cancel, I'll divide both sides by 2. Wink, 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 wink. There's 1 on top and 1 on bottom. And so now I just got V squared, so that's neat. And 50 divided by 2 is 25, huh? Huh? You see what I was doing there, changing it to 50? Nice. See, now I don't need a calculator. A lot of these you don't need a calculator because you don't have that 9.81 like we did yesterday. All right, so that's V squared. We're not done yet. We got to get to V. So we got the square root. The V squared is V, and the square root of 25 is 5. And that's V, so velocity is measured in meters per second. So I gotta put my unit on there. And then I'm done.
So did you do 1/2 times 4? That's it, right? For that too?
Yep.
And every single problem's gonna have it where you have to put that square root.
Yep. Well, no, not every single problem will have the square root on it. Sometimes it'll give you V and it'll ask for KE and you'll just do 1/2 times this squared. Remember when you do those, make sure you square this first due to order of operations. Thanks for reminding me about that. So like, you'll do, if this ends up being 3 or something, you'll say 3 squared is 9 times m times 1/2, and then you're good. But order of operations says do exponents first and then multiplication. Y'all remember what this big check mark is called? Starts with an R. Cover your nose. Cover your nose.
Radical.
Radical! Far out. That's right. Okay, thanks, Abe.
Wait, that was right?
Riley. Yeah, it's a radical. Good.
Oh.
That's all I got to say about that.